Frederick. Great to see you again.
Hi, Bill. Great to be here.
Well, today we're going to talk about power sources. But to start with, can you tell us what's an ideal diode?
Oh, that's a good question. So an ideal diode is actually using a MOSFET, like a P-channel MOSFET or an N-channel MOSFET to mimic a diode to make
Hmm.
sure current only flows through the device in one direction and not in the other direction. And the idea behind it is that the voltage drop is somewhat lower than when using a real diode. It's quite interesting. So if you use LT Spice as a simulation tool, within such a simulation tool, you can actually have a real ideal diode with no voltage drop whatsoever. But what we call an ideal diode in the industry typically still has some resistive voltage drop, of course, but it's lower than a standard diode.
So, how does this give us a more robust power supply?
Yeah, so the thing is, if you want a real robust power supply, very often you would use different power sources. And let's say a battery and a wall wart or something like that. And if you have, or two parallel different DC to DC converters. And if you have multiple power supplies, you have to make sure they're not back biasing through the power supply that's not actually operating or working at a given point in time. And so for these things, for a real robust power supply with redundancy, you need some sort of diodes in the power path, but nobody really likes to have a diode in the power path because the voltage drop, if
Hmm.
there's a lot of current running through them, would give you lots of system power losses. And so that's why ideal diodes and now I mean with an ideal diode, just
Hmm.
using a MOSFET as a replacement for a diode with a lower voltage drop can really help to reduce the power dissipation in the system, but still giving you the robustness to have multiple power sources in parallel, so to say.
Well, great. They can check out the article for the details. Thanks a lot.